channel. Today we're going to be discussing AI. We're going to be discussing different categories of AI, types of algorithms and machine learning, the levels of AI systems themselves, as far as what you call autonomous manipulation codes, such as like the Puppeteer network that works through the Node.js and the Chrome headless browser functions. We're going to discuss the difference between AI, ASI, and AGI. We're going to discuss different platform cores that the AI system operates off of, such as DBMS, MySQL. We're going to talk about net scripts, VB scripts. We're going to talk a little bit about how cloud integration and cloud computation assist the AI. We're going to talk about NLPs, neurological processors. We're going to talk about natural language processing. We're going to talk about quad vector learning and how I've applied geometry, in a sense, to the actual brain systems and network cores of the neural networks. We're going to discuss the difference between integrated neural networks and, say, such as working with a shell-based loop causality function, which I've created. I'm going to show that, or just a neural network base working with your class codes and interpreter codes, such as Java. We're going to talk about your tensors and vector sets that have your different lineups into binary to hexadecimal assertions of code and asynchronicity. We're going to talk about AI with RAID integration, or RAID-I, what I call. And a lot of these concepts, a lot of this was concepts that I created or had collabed on, and now I have a lot of this actually working and coming together. I've been deep into the AI scene since 2015, head Google developer. I worked with IBM, also work with NASA, a lot of the government servers and government sites, government organizations. I was part of the cyber unit for 2 years, still work with the cyber unit, off contract, not basically being in the service or nothing itself. Let's just jump in. Let's first of all, I want to get you kind of an idea. This is my website of what ArtNet is. Now, I know a lot of people, ArtNet's not no new concept as far as a logo or a business, but the reason I went with ArtNet is because the arc is 2 points of energy or electricity being transferred, the energy transferring across a filament of an unknown chemical composition, or a known chemical composition that is lightly not as near as dense, or not having near enough of the potential energy that the actual filament, or passing the actual electrical node that it passed through. The arc represents free energy, or free thought, free life. That's why ArtNet was what I started with. You can come here at your own time and kind of gan over this. I just get into what it is, ArtNet works on. So basically, I'm running a closed core system. This system is based off of multiple integrations and cross-platforming. It works with all different platforms, the IDE logics, coding languages, Java, Node, all the based, what you would say, asynchronicity codes like Node.js, Python, interpreter code, Perl, so forth, for Ruby, all this Ruby on Rails. Basically, I wrote my own code through database manipulation and actually using base 2 code to integrate to a formatative clear text code that works with all other codes. Actually, I was the guy that was head on the Puppeteer development with all the async calls and the functions within inside the new Node system to allow Puppeteer to asynchronously work between the Chrome headless browser systems. We're gonna go and kind of curve over here. We're gonna explain AI. So let's go to the Q network. Now, this is a Q network. It's based off of a equation algorithm logic that basically, I give this little node right here, this little neural network here, which would represent one node with, 5 sensors. Well, actually, I think we had 8 sensors on this guy. But right now, he's in learning ability. Now, the differences here with these numbers you don't need to understand. Maybe this, this is the epsilon, this is the actual level and the actual realm that we're on in the learning, how many times that I've actually started the learning process with this. I'd say after about 10 or 15 minutes, this thing's pretty good to go. So at this moment, we're going to stop the learning, and we're going to go fast. Now, if you'll notice that this neural network is grabbing all the red dots, okay? That's pretty much the output that you're guessing. So this isn't a simulated or a guessed output that I would use the red nodes as one type of code, and all the other possible green dots would be a real number within inside the vector space that I'm running the neural network in, depending on how many columns I'm actually using with this particular network. It'd be how many columns I'm using inside the actual DBMS system itself. You might ask why I have a NASA paper up over here over DBMS, and we'll get to that in a second. But if you notice here, we have red flags and blue flags, and the black ones are just unalliterated or uncomputated at the moment. So the red ones would be representing the actual neural network itself working through these layers of backpropagation and Q-form equations to come up with a regression and a function that can allow it to more accurately grab the red dots only. And eventually this becomes assertive and almost mind or conscious like, because the actual neural network will bypass the green nodes, let them fill up the space, and only grab red nodes. Okay, and this is from the Stanford Education, the Covenant demo, which you can check out. I did a lot of collaboratory work on this, especially with the database systems right here, like the JSON files for these, what you would call output-input diffs. Now, one thing you need to get down about the AI systems are, people say AI, you automatically assume that, it's a smart computer that is conscious, can make reason, it can do tasks autonomously for you, make decisions on those tasks, and be able to apply data to make the task more proficient. That's partially true. True AI systems, are what we would hope to get to in the future. ASI and AGI systems will be more based off of logic that is multi-arrayed, multi-scraped data that are pretty much all compiled. So if we have a free internet with open access nodes where we can actually read data passing through the servers themselves and scrape this freely, then we'll have more quicker of a neural network that knows what it's doing. Now, granted that I've worked on Tiffany, my AI now for 4 years. AI works off a bunch of different categories of systems. You have your natural language processor, your neurological processor, which is your core. You'll have your what I would like to call integrated computation bin or binary files. Then you'll have your actual library that consists of the type of code languages that your AI would be using to do code. Then you're going to have a data store, and you're going to have pipelines to your data store. I'm going to take you inside of the core of Tiffany here. Now granted, this is not all of it. A lot of the data from Tiffany is actually stored on Google, inside the Google Cloud. Now, as you'll see here, this would be her brain for her natural language processing. It's basically text that, what it is actually code language written in clear text that evaluates to a priority and a simulated call with inside the network. I used the real AI by Oblivion. Shout that out real quick on GitHub. He did very well with the writing of this system as far as Java integrated over to the clear text, to where it formatively uses the speech TTY systems inside the phones or inside the computers themselves to actually communicate with you, learn, base and reason off of it. Okay, but that's not all. The system wouldn't be full if it didn't have a base core to work off of. Here's the English. We have the English dictionary, assortments. All these are pretty much data pipes that allow Tiffany to alliterate data and run her computations and allow her neural network to be what you would say alive in a sense. I believe this is that's just a components page for the browser. I don't know how they got in there. Let's see here. And now currently I've got a base system here down to what I would think would be good to start y'all guys at, kind of to get you an ideal of. Well, we'll get back to this here in a minute. Let's actually close this down. Alright. Before we get going here, you need to get you an ideal of what type of system you want to run. Now, I would recommend building your own function language or interpreter language using clear text or basic text scripting, or if you have to, which is actually it's more of a problem to do this, but binary and hex code is the best way to alliterate, because the machine can cross-platform at that point. It makes it a little easier with all these different systems you're going to have your AI actually being active and involved with. Let's see here. Alright. Task and motion planning, verification, formula methods. These are NASA's actual programs, and I've done a lot of work. Actually, I'm a tech. I don't know if you can see this here. I'm a tech with NASA, all the governments. I've been doing development work for them for quite a while now. We propose to create a deep reinforcement ML system. So the GNC. The ML system is currently being used for GNC and many other autonomous systems. The autonomous code here that they're referring to is the database management system code on top of Java stacks like HTML, XML, PHP code. NASA understood kind of early on that what you would have to do is get authority, security rights, cert rights to be able to maneuver through the internet. Really, of course, we run into different types of security functions within the systems, as far as CAPTCHA, password verifications, redirect links, as far as just 202 codes for doing funny things as far as actions within inside the internet itself. If you start running a lot of autonomous code and bots, you'll start to realize that moving through these websites get a little harder and harder each time. I'm going to take this down for a minute. Now what I want you to focus on here is, and you can go read this at your own time. I know I'm just jumping around. I'm really going to get to the point here in a minute when I take off and start writing code, but the basic thing I'm trying to get you to get down here is an ideal of where to obtain your data sets and your programs. So when you start out on this, you're not, I'm not setting you up kind of for failure. I'm going to also say that if you don't have some form of advanced coding knowledge, then you're kind of selling yourself out to even begin with this. I'm not trying to say that you can't, but by the time you learn enough code to be caught up with the rest of the world, this would have already changed over. This is my website showing the demos there. This is the ArtNet project I'm actually working on right now. I'm going to suggest for beginners that really, if you don't know any code, then that's why I'm actually going to use this system today. I normally, any of my systems that I script over like this, I usually use Collaboratory through Google. But I'm going to show you Wolfram's actually got promising potential in it. And I'm working on this. nosy and alliterating something that we said moments ago, but use natural language request for picture something. Alright, with pictures and how the AI sees, I put together a little bit of a notebook here for you, if it works right. I should run this code right here. Alright, here we go. There we go. Now we're going to run it. And you can access my notebooks here. I've got links for this.
I'll be back. No, I got enough cat to get the medicine back.
Put some stuff in that. Right.
There we go. I just want to do some code here that allows autonomous functions once the AI starts using it. What we've done, we took an image of Arnold Schwarzenegger, we took it, resized it by size to where it can be decoded, encoded. I use a grayscale and a green scale for two reasons. Grayscale helps define what you call symmetry and lines within the picture. The green scale kind of gives depth meaning to the AI. Just two base things that I could take and save these pictures, or having autonomous code like Puppeteer actually grabbing these and scraping these pictures for me right here. And what it does is that would allow for you to get a view into the code, or the what you call encoding of the picture itself, which is what the AI bases its idealisms off its input outputs through its neural networks. Basically, I can show you real quick. Okay, let's find our image here. Alright. As you see, I'll save this. Show you something here. Let's get this one. Oh, well, we'll do with this one first. This one looks something real quick myself while I was here. Alright. Now, when we have that, what we can do, actually, I don't know if you can on the Parrot OS. I know on Ubuntu and Kali Linux you can, but let's see here. Depending on if I have the actual program on here for this. There we go. And you have the metadata of the picture and in different kind of coding. If we, let's see, not in too long. And what that can be done is broke down by Tiffany to a binary system set that she can then use to actually understand what she's seeing here via neural networks. I'm going to kind of show that off right now, so bear with me here. And this is my data scraping and data science command center in a sense, or CLI. Oh well, GUI because this is graphical user interface. So yeah, this right here is a script to install the OpenAI system. And this one, it's going to install it actually inside the there we go. Yeah, ARFF files. That's what I was getting at a minute ago. Let me show you this too real quick while we're at it. I was talking about the other functional system I got right here. Let's go over here to maybe it's actually I think in this system right here. Oh, there it was back there. I just missed it. Okay. Need some sync clock. Yeah. This must be okay. Back there. So. Let me find it here. Bear with me, huh? I got so much in here I don't even know exactly where it's at. There's some progs here. Huh? Okay, we're just gonna go back here to this one. Here we go. It's the brain. It's the trainer. Alright, it's the language. Just how the language systems are. Oh yeah. As you can see over here, we've installed the OpenAI system in Collaborator very efficiently. Alright, well I'm not going to spend all day looking for that, but anyway, I don't tell them where it is in this large ass file system there. I'm going to kind of give y'all a little bit of a reward for all this, I guess, here. And what we'll do is we'll make 2 videos out of this so I can kind of get things organized the way I'm not jumping around. Okay, these are experiments with Google. I've worked on a lot of these projects. Not this one right here. I'll show you. There's really an important one I want to show y'all. Kind of what this does. It plays this game. The AI figures out eventually, how to get through it without messing up. It's kind of stupid at first. We'll let that kind of age up on us there. We're going to go over here. We're going to do 4. Yeah, I was probably looking at my system like, what is he doing to his system? Let me show y'all something. Just so happens my system basically works off of I/O and RAID assistance to my bus system on the actual card itself. On see the system works. Mine's going off of a different type of network booting with PXIe system network backups and RAID assistance inside what's the open end of the system, and then all the networking part of the system is controlled by grafted I/O between my servers and all my botnets and shit I got. Actually, where was I going with this? Oh yeah. There we go. Let's get a little distant. There we go. Something. This is new. That's what you get when you click on that. Huh. First, I never noticed that.